Okay, welcome to the graphing tutorial for Chemistry 1. We're just trying to increase everybody's skills in the graphing department. We didn't really like what we saw in this last lab. So what I have here is I have some data, time spent making the graph, and the score that you receive on the graph, just as a hypothetical situation here. Okay. First thing, with your empty graph grid, the very first thing that you should always do with a graph is create your title. And your title needs to have both variables. So my variables here are time and score. I shouldn't make some cutesy title like Smarty Pants unless I have a subtitle explaining why I'm calling this graph Smarty Pants. So in this case, I'm going to keep it nice and simple, and I'm just going to title it Time versus Score. Okay. All right, second thing that you need to do is axis labels, okay? We have an X and a Y axis. Our X axis is for the independent variable, our Y axis is for the dependent variable. So which of these depends on which? Well, we don't score the graph until after you've spent the time making it. So your score depends on the time. So your time is your independent variable. The independent variable goes on the X axis. Okay, dependent variable goes on the y-axis. Once you write your variables, they need to have both what is being measured and a unit of measurement. Okay, so on my x-axis, I'm going to put my independent variable, time, but I don't want to leave it like that. I need to have a unit. Seconds. Okay, on my y-axis, I'm going to write my dependent variable, score, and again a unit, percent. Okay, I could have abbreviated that with a percent symbol, but writing out the word percent works as well. Okay. When you're making a graph with something like amount in chemistry, amount always means moles, not mass. Okay, so if that was one of your mistakes, go ahead and fix that. Okay. After we've placed our X and Y axis labels, now we can think about scale. Okay? There's a couple things to think about. You want to start ideally a little bit below your data and end a little bit above your data. Okay? You also want to have consistent spacing here. Okay? Now if you look at the data, 30, 60, 90, 120, 150, that's all consistent, adding 30 seconds every time. Okay, but then I get to here and I'm only adding 10, and here I'm adding 15. Those are inconsistencies in this scale. That's okay when you're taking data, you might have inconsistencies. But when you place that data here, okay, this needs to be a continuous scale. Every square on a graph needs to represent the same amount of time or the same percentage change in your score. Okay? The only way to get away from that is to break your scale. And you can break your scale. For example, you can break your scale right here. Our lowest score is 30%. We don't need to start our scale at 0. Okay? We can start at 30. So if you want to break the scale, you can skip right to 30. Okay? And then you can space out your data a little bit better and use the space in your graph. You really shouldn't start at 0 unless you have a data point that is near 0. Okay, it just wastes space on that graph. Okay, so I'm going to, every third line here, I'm going to up the score by 10. You cannot break your scale in the middle. Now if you see in our data, we went from 30 to 60%. I can't break and put a 60 here. The reason why I can't do that, or I shouldn't do that with this data, is because you need to be able to see the shape of your graph. And if you compress a part of your graph, it's going to dramatically affect the shape that you see when you have all of your data points graphed. Okay? So on my x-axis, I'm going to do a scale of seconds. I need to get all the way up to 175. I think I can go ahead and start that one at 0. And let's see, 20, 30, 40, 50, 60, 70, 80, 90, 100. Oh, this isn't going to work. Okay, so let's see. I'm going to change this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to get all the way up to about 180. So I'm going to change these to 20s instead. So that's a 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. I don't need to go that far. Okay? Okay, next up, number 4, graph all of your points. Now when you graph these, you want to make them obvious. Okay? Don't put a little tiny mark that when you draw your line, the mark goes away. You can't see the mark anymore. Okay? You need to have a solid point, and you need to make sure that they are correct. So double check before you actually draw your data point. Here I have 30 seconds, 30%. Okay? 30 seconds right between 20 and 40. 30% is right here. So that is my point, 30, 30. I double check it. I add that point. I make it nice and obvious. Okay? 60 seconds, 60%. Okay, so this is my 60% line. This is my 60 seconds line. I double checked a couple times. Okay, 90 seconds, 75%. So 90 is between 80 and 100. Okay, 75 is going to be smack in the middle of these two lines, and those meet up right there. Okay, 120 and 85%. 120, 80 is right here, 90 is up here, so halfway between those two, I'm going to place a point at my 120 mark. Okay, 150 and 90%. So 150 again right between these two. Okay, make sure I don't lose that line on the way up. And 90% is right on the line here. So that one's an easy point to graph. 160 is 100%. Okay. And 175 is 100%. Now 175, a little trickier, it's actually between this line and this line, so it's in between these two lines, and it's 100%. Okay? Alright, is the data perfect? No, data is never perfect when you're a human being, okay? We're not going to do a connect the dots game, okay? So our final step here is to add either a line or a curve of best fit. Okay, so for this I would recommend using a pencil, okay, but you need to look at your data. Do I have something that is a linear relationship, or do I have something that is an exponential curve? Okay, does it look like my data is doing a curve? I think it does. Okay, does it look linear? I guess you could probably make an argument for that, but can you get over 100%? No, this one is going to be a curve. Okay, now if you're ever in question about that, ask. I'm sure every teacher would help you with that decision, whether it's a line or a curve. Now if it's a line, again, never connect the dots, but you're going to add a line of best fit. And there's this fancy tool that was created, a long time ago. It's called a ruler. Okay, grab one out, use a piece of paper, use a book, use something to get a straight line. It's absolutely obnoxious to grade a graph that doesn't have straight lines. Okay, now this one, I don't think this one is a straight line. I know it's a curve. I just made this data up. I wanted it to be a little bit off. Okay, but in a curve situation, you're going to try and add in a curve here as best as you can. Okay, the asymptote of my curve is 100%. Okay, so these two are going to be on the curve, okay? And your data points might not all fall on the curve, okay? You can extend your curve beyond, okay? And you can extend it beyond on this end as well, but you should attempt to make a nice smooth curve without hitting every data point unless your data happens to work out really nicely, okay? And that's it.